Could you run or walk in the rain? It is the oldest street dilemma. You're 50 meters from the nearest awning. The sky is trying to drown you. Do you walk slowly, minimizing your speed and the amount of time your body slices through the air? Or do you sprint like a hero, minimizing the time you spend under the dulge? The goal of the course is to get least wet. The goal of the course is to get least wet. Yes, it feels like a paradox. Common sense argues both sides. But we don't use common sense here. We use calculus and a little bit of fluid dynamics. And today we are going to prove them mathematically the optimal strategy for not looking like you just took a quick dip in the Atlantic. To do this, we need to treat the water you accumulate as two totally separate solvable problems. Number second, the two components of wetness, sorry. Your total wetness, W total, is the sum of two variables. We call them vertical rain and horizontal rain. So the total wetness is equals to vertical wetness plus horizontal wetness. First, vertical wetness. This is the rain falling straight down, hitting at the top of your head and shoulders. This amount of water is defined by your top surface area. Let's call it AT. And the time T you spend outside. The faster you move, the less time you spend outside and the less vertical rain you catch. So we can say that the vertical wetness is directly proportional to the total area multiplied by time. Now, horizontal wetness. This is the rain you are running into, the rain hitting your chest like a windshield. The amount is defined by your front surface area. Let's call it AF and the distance D you cover. So we can write is horizontal wetness is directly proportional to front area multiplied by distance D. So now I will give you the mathematical proof of this condition. Now let's look at the full equation again. We will introduce a couple of constants like C1 and C2 to account for the density of the rain and your body shape. Wetness total is equals to constant 1 into total area into T. That means total time, plus C2, the constant number 2, multiplied by front area multiplied by the distance. Here where the math simplifies everything. Which variables can you change? AT, total area, and the front area are fixed by your size and shape. D, the distance to shelter, is also fixed. That means the entire horizontal term, the rain you plow into, is a fixed constant regardless of your speed. The only term you can minimize is the vertical term, and it's dependent entirely on T, the time you spend outside. Since T is defined by the distance D divided by your velocity V. So T equals to D by V. To minimize T, you must maximize V, as T is inversely proportional to velocity. Now, the mathematics is unequivocal. Since the extra water you hit while running is fixed by the distance, the single most important factor is minimizing the time you are exposed to the vertical rain. The only way to do is that to run as fast as you possibly can. QED, the greatest paradox solved. Run! Now, but this is an ideal model. We assume the rain falls perfectly straight down and that you are a perfect rectangle. In the real world, we have to consider wind. If the rain is falling diagonally due to wind, running still helps, but the optimal strategy gets a little more complex. Your speed relative to the wind means the rain vectors change. Physics models show that if the rain is coming from the behind you, you need to run at a specific speed just slightly slower than the wind to match the rain's horizontal speeds. That's how you minimize the relative velocity. However, in almost every practical scenario, especially when you are a small object with a fixed distance, the mathematical benefits of minimizing your time outside still overwhelmingly outweighs the minor increase in relative speeds you experience from the diagonal rain. Unless the wind is blowing so hard that the rain is moving faster than your maximum speed, you should always sprint. So, the conclusion. So the next time you hesitate in the rain, don't worry about philosophy. Don't worry about looking silly. Just remember the simple truth. Time equals to distance over velocity. And always remember that time is inversely proportional to the velocity. Minimize the time, maximize the V. The math has spoken. Sprint! Come on, guys, sprint. Whenever you saw that the rain is coming, just sprint. If you enjoyed us over analyzing a simple question with a ridiculous amount of math, hit the like button and tell me in the comment section what other everyday discussion needs to be solved with differential equations. I hope you like the video. If you like the video, then subscribe the channel. Thanks for watching. Bye bye.